Okay, so for the previous assignment, we were supposed to add a resolve statement to our language. And remember, we decided that maybe for our output of our interpreter right now, it would show, because a resolve statement, it accomplishes something, but we're going to use it in a bigger context with some other abilities. So I suggested maybe the output should be like, a little flag that says it's hidden, and then, whatever the value was, just to kind of indicate that we did get the value, but we didn't necessarily do more than that. Let me get to the parser. All right, so right now we're reading in from our spider, and here's our current spider code, where we have 2 remembers, then 2 resolves. Right now it's only going to work for the remembers. So when I run this, it shows me let me move this a little bit. It shows me the current variable environment, and then it shows me the 2 values that it's stored in there. So it shows that I put an a = 5 in the variable environment and a b = 7, but it's not showing me the resolve aspects of those, which are these statements right there. So when we resolve them, we should get a value of 5 and 7, proving that it goes both ways. All right, so let's go into the spider interpreter, and actually, let me see, do I already have a resolve statement in here? I have a resolve statement that just takes in a name and has a 2-string for it. Okay, so let's look at our spider interpreter. So when we tell it to interpret, right now we're saying if something is an instance of a remember statement. So what we need to do is make sure our parser is doing its job first. So we have a parse resolve, we have a parse remember. When we tell it to parse, we read in from our file, we get the each thing. We tell it to parse the statement. Parse statement says what? If it's a remember, do this, add a parse remember. If it's a resolve, do this, add a parse resolve. So we should be parsing it correctly now. So we wrote that the previous class. So now we should be asking, well, if it's an instance of a remember statement, do this stuff. Else if S is an instance of a resolve statement, if it's one of those guys, then we want to interpret a resolve statement. So we're already interpreting a remember statement. So let's go ahead and I'll just steal this. We'll interpret a resolve statement. And this guy will take in a resolve statement as a parameter. And instead of adding something to the environment, we're going to ask our environment to get us a value, the value of what? RS, I misspelled this. RS get name, so the name of the variable we want to resolve. Now get value is going to return for us, it should return a, where's our variable environment? Get value assumes everything in our language right now is an integer, so it's going to return us an int. So I'll go ahead and capture that int inside of a variable. And then for our output, we'll have maybe something like this. Resolved equal answer, something like that. Oh, and remember we added exception handling to our variable environment. So we said that get value actually throws an exception like this. So we'll go ahead and try to get the value and then have an error if it's not found. So we'll go ahead and we could actually do this as a runtime exception, but let's leave it as a normal exception here, and we'll just handle it in here. So we're going to say we're going to try to do all this stuff. And then we will catch exception E, and we'll say something like system.err.println, that's error. We'll say variable not, here we'll put a little rs.getName, we'll say not found, like that, and then we'll say system.exit, and we'll just give it a status of 1, whatever. That's for like error codes. I'll just do something other than 0. That way we'll have our interpreter will actually crash on that. And I'll show you that in a minute. All right, so we want to go ahead and, just like we did up here, we're going to call our interpret resolve statement. And we're going to pass it the resolve statement version of S. That. And now when we run this guy, we see that we have our 2 resolve statements that are handled now, resolved A to 5, resolved B to 7. But now just to see how that error handling worked, where can I put this to make it, let's go that route for now. So I'll go ahead and I'm going to change my spider code. I'm going to say resolve Z. Now, if we were writing this code, we know Z doesn't exist in our environment, right? So if we were writing this code and it started interpreting it, it would handle this line, then handle this line. And when it gets to this line, that's when we're going to have that exception for the variable not found. We don't want it to keep going. Once we've killed our program right here, we want our program to kind of die, for us right now, kind of a horrible death. So when I run this now, you see variable Z not found. So we get that exception, the error thrown at us, so we can go back and edit our code.
I have a question.
Go ahead.
So in the input.spider file for the resolve, we only have the variable A and B, and we are getting the values of A and B. So are we passing the values here, or I was just thinking that we are just creating the resolve A and B, not passing the values for A and B.
This is where we're remembering them right here. We're remembering A is equal to 5, we're remembering B is equal to 7. Then we're resolving, before I had it this, so I said resolve A, which should give us the 5 we just remembered, and resolve B, which should give us the 7 we just remembered. So we're not passing them to anything yet. That's why we said we would make it hidden, because we're going to be using these guys as part of something else. Today we're going to be looking at like Boolean expressions as we keep working through our language. So, but the point is, we were able to prove that we can resolve the value of a variable to its value. Does that make sense?
Yeah. And
okay.
can you go back to the spider.interpreter? And then under the remember statement function, interpret remember statement. Yeah. So we using the add variable function here, using the object, and we are passing get name and get int value as a parameter using the rs. So I can't understand, like,
RS
Because
is a remember statement. The name of that RS's name is going to be like A. RS's value will be like 5. We're adding A equals 5 to our variable environment.
okay.
All right, so this would be the solution to the previous assignment. I'll go ahead and push this up to GitHub so you have the most recent, let's see, updated for homework for resolve statements. And so now that's up on my GitHub. All right. So let's go back to Keynote here. Oh, that's not us. This is us. All right, so as we're continuing to build this language, remember that we've advertised that all programming languages have facilities for memory, asking questions, and repetition. So we've just proven that our language now has the ability for memory. We can remember variables, and then we can resolve those variables, pull them back out of that variable environment. Great. All right, so now that we have that, the next thing would be asking questions. So in a programming language, when we say asking questions, in our typical programming language, this is going to be done through something called an if statement, right? We're thinking about like Java, C, C++, whatever. So it's usually like if some kind of Boolean expression, and then we have, the what to do if Boolean expression is true, and then we might have an else, and then a what to do if Boolean expression is false, like that. All right. So before we can, okay, so that's what an if statement might look like in other languages. We can decide what our syntax is going to be for Spider. But for us in here, we need to, before we can do something like this, we need to support Boolean expressions, right? So what is a Boolean expression? So tell me, what's a Boolean expression?
Just true or false.
Okay, so it's any expression that boils down to a single value of true or false. All right, so we need to have expressions that boil down to values of true or false. Can you give me some examples of expressions from our modern programming languages that might boil down to true or false using integers? Because right now our language only supports integers, right? All right.
So if 4 modules 2,
So for mod 2.
yeah, yeah, the mod 2
Yep.
equals to 0 remainder, which returns true.
Okay, so we see something like that. Could we also say something like 4 less than 8? 4 greater than 8?
I think so.
Yeah, I mean, this is 4 less than 8. Is it true that 4 is less than 8? That's true. Is it true that 4 is greater than 8? Nope, so that's false. Is it true that 4 mod 2 is equal to 0? That's true. Okay, so we have a series. So we build Boolean expressions. Let's just call these arithmetic Boolean operators. So we have this idea of something called an operator. So we build Boolean expressions for numbers using the operators below. So we have equal to, we're just kind of going off Java syntax here. We have less than or equal to, we have greater than, we have greater than or equal to, we have not equal to, something like that, right? So those are our base arithmetic Boolean operators. We can ask if something is equal, if it's not equal, if it's less than or equal to, greater than equal to. Make sense? So we should be able to build Boolean expressions using the numeric Boolean operators. So in our language, we might go into our input.spider. Maybe we do something like I don't know how. Ultimately, I want to do something like this: Boolean a less than 5 or a less than 9, something like that. Really a 9 like this, because right now our yeah, I think we can handle it. We can say Boolean a less than 9. We can also say something like Boolean a less than b, something like that. Okay. So with that in mind, we want to, now we can change these to be different names if we want. I mean, do we have a better name than Boolean for our spider language? Boolean's kind of a I don't know, kind of a programmery type term. Do we have a beginner doesn't know how to program type term that replaces Boolean? Keeping in mind, we're going to have a question in a few minutes where we're going to ask a question about something. So is there something else we want to say here? Or we could even just not label it. We could just say a less than 9 since we won't. I mean, is that self-explanatory? Is this something that a beginning programmer would be able to handle? Probably. Fair.
Does it only limit to 2, 1 before the arithmetic, the logical operator?
What do you mean?
So how about what does it support a plus b less than?
Oh, so something like a plus b less than 9? Well, our language doesn't support plus yet. So we can, so, okay, so maybe before we do Booleans, maybe be able to do math. Yeah. Okay. So before we even can get to asking questions, maybe we can say we want to add the ability to do math with our variables. We can now store variables, we can resolve variables, maybe do math with those variables. Okay. So we need to add operators for plus, minus, times, divide. And if we want, we can put modulus in there. We want to be able to do that too. All right, so we need to be able to do some math. So if I back up here, we should be able to say something like do math a plus 5, something like that. And that should resolve to something, right? Okay. So we're going to go ahead and have a do math my parser. So we'll do a do math statement. Now remember, right now we have this basic idea of a statement and a statement type. We've built two different statements, a resolve statement and a remember statement. We built those guys in terms of statements. So I'm just going to steal everything but the body there, or the header. I'm going to go ahead and say I want to create a new class, and we're going to call this guy a do math statement. And for right now, I'll just start it off as being the same thing as my resolve statement. But we'll say the do math statement will take in a, it's going to take in a couple of things, right? It's going to take in, we need a first part, a second part, and an operator, right? In order to handle that. So we'll come back to this here in a second. I'm just going to call this do math statement here. So we'll leave it like that for the moment. We'll update it. So now, as we go through here, if I go to my input spider, really, this guy right here is inaccurate. I need this to be a resolve A plus 5. That makes sense? That's what I ultimately want to accomplish there. I need to resolve the value of A. Now, the question is do we want the person who's programming this to have to write that? Or do we create a statement out of this? When we see A, we see something that's not a built-in literal. So in a modern programming language, if I'm walking through this and I see a statement that's like this, do math A plus 5. This is the first part, this is the second part, this is the operator, right? When I look at this 5, I'm going to ask myself, is that one of my literal types? That is that like a letter of the alphabet, or is that a number? Is it one of the known characters in the Unicode character set? Or is it something else? Okay, 5, we're pretty quickly going to say, oh, that's just the number 5. That already has meaning, doesn't need to be resolved, right? Okay, so that kind of, let's say that side is fairly easy. But if it's not one of our literal types like this, then we need to say, well, for instance, I'm looking at A here, and notice it's not single quote A single quote, even though that doesn't exist in our language yet, but it's just, as our humanizer telling us, it's just the name of a variable, right? And names of variables need to then be resolved. All right, so we can have a specific resolve statement here, or we can go ahead and say, I'm going to build a resolve statement because I need to get the answer of this guy before I can go ahead and do this math. So any way you cut it, I need to resolve this and I need to resolve this. Things that are literals, when we resolve them, they resolve to their value. Make sense? Okay. Things that are variable names like this, they resolve to their whatever the variable environment tells us they should be. Well, it'll resolve to its value, not necessarily, yeah, not to the type. So if we go back and we look at our resolve statement here, when we have a resolve statement, we're taking in right now a name, right? We're presuming this is always going to be a variable name. But can we also, could a resolve statement also possibly hold a, yeah, for instance, yeah, right now in our language, you could also hold an int, right? And we can pass it an integer that is just stored in a string, since we're always taking strings in here. But ultimately, when we resolve this guy, so let's go into our interpreter here. When we see a resolve statement like this, I'm right off the bat telling it to interpret resolve statement, which is down here, and I'm just assuming that I'm going to look up that name in my environment. I actually only want to look it up in the environment if it's a variable, which for us right now means it's not a number. So we're going to say only look up the variable in the environment if it is not a literal. And then maybe I'll say literal types for us right now is just int. All right, so we'll ask if rs.getName, okay, that guy is a string. I want to find out if that string represents a integer. Make sense? How could I do that? How can I find out if this entire string is an integer?
All the characters are digits.
Okay, so I could write a function that checks to see if every character is a digit. We'll go ahead and let's go through that exercise. All right, it's not the best way of doing this, but we'll do this exercise anyway. So we're going to say private static Boolean, maybe call this guy is integer. And it's going to take a string s as a parameter. And we want to go ahead and go through every character in s. So for int I is equal to 0, I is less than s dot length, I plus plus. And we want to ask if the current character we're looking at is something other than an integer, return false. We get all the way here, we can return true. We check them all. So how do I ask the question if this guy is, if current char is not an int? How would I accomplish asking that question? Well, I'm looking at an individual character. So there's probably something in the character class that allows us to ask information about characters. So we can do something like character dot is digit. And I'll pass it s dot char at I. So that'll return true if it's a digit, false if it's not. So then I want to say if not character dot is digit. If it's something other than a digit, go ahead and return false. Otherwise, check the next character, check the next character, check the next character. In the end, return true if I didn't find anything that broke. Right? So I can come down here now and I can say, well, if, what's this class called? Spider interpreter. If this guy is integer, rs.getName. So if it's an integer, we're just going to return, well, we'll output spider for right now, just to prove it's working. Actually, we're just building a string out of it. So we won't resolve it to anything. It's already its value, right? All right, else. We'll do what we did before, where we'll actually look it up in our variable environment. Good enough? Okay, and let's go ahead and see this work. So we'll go ahead and go to our input.spider, and I'll go ahead and say resolve 7, like that. So now we should see for our last pass through that 7 is equal to 7. All right, it was able to resolve a literal for us now. Okay, now I'm not going to spend too much time on this next thing, but I'm going to say that yes, this works and nothing's wrong with it. So if you could come up with this, and it's a good way of checking to see if something is a all characters, although I'm guessing most of you didn't have this just in your mind. could have gone and looked it up pretty easily. Is a single character a number, something like that. All right, but this is fine. Is there an alternative way we could have asked this question?
Java has a try-pass integer.
Well, it definitely has try catch because we've already used it in a couple places.
I say pass it into the integer and make it fail.
Yeah. So the way I would have written this is I would have said, let's try to do some stuff. What stuff? I'll try to do integer.parseInt of rs.getName. And if that works, so we'll say int answer is equal to that. If that works, then I'll go ahead and do that. Else we'll catch exception E and do something else. What will we do? We'll look it up in our environment. All right, so we'll go ahead and actually, to look it up in our environment, we also then need to do a try. And then a catch here. All right, so we're going to try to parse the name into an integer. If that fails, we'll catch the exception because it couldn't turn it into an integer, which means it must be a variable name. So we'll go ahead and treat it as a variable name, and we'll try to look it up in our environment. And if we fail to look it up, that's where we have our error message. Otherwise, we either look it up in our variable environment or we get it as just an int, one of the two. And we'll see this guy. Try to do that. Call this exception E2 because we already had a variable name E. And there's our 7 is equal to 7. So still works. Either of these are okay approaches. You can decide, do you want this extra function to determine if a string is an integer? If you do, it's fine. You could have also taken this stuff in there. So you could have taken that string, pulled it inside of his integer and done the same try catch thing in there and returned a true or a false. All right, so we could have accomplished it either way. Pick your poison. So this guy determines if a string contains all digits, all numbers. Whereas this try catch attempts to convert a string to an int. And if it fails, it looks the string up as a variable name. That type of thing. They both ultimately accomplish the same thing. All right, so now we have the ability to use literals. We might have to tweak this a little bit as you're going to start seeing as we start putting these things together. You see here in our input.spider here. Let's say that I want to do something like do math a plus 7. And I'm going to go ahead and put a semicolon at the end of that because like we're doing little pieces, right? But realistically, we would probably do something like if this was in real life, we would do something like remember C int c is equal to do math of a plus 7. That's what we would really write, correct? We want to remember something. What do we want to remember? A variable named c of type int. And what is its value? Its value is going to be the result of calling do math on a plus 7. Okay, and how do I do math on a plus 7? It's going to be the result of resolving a, adding to it the resolution of 7. So you see how up to this point, we've handled our lines of our code by each individual component ending in a semicolon, where that's not what we're doing right now, right? You see how things are going to start getting more complicated with our parser? Our parser needs to go a little deeper. Up to this point, we only had 2 abilities. We could say, I want to remember something and I want to resolve something. And we just said, both of those have semicolons at the end of it, move on with life. Well, now we're going to start having more complex statements where this guy is a single statement, correct? It's a single statement that has within it a couple of expressions. So the reality here is we would never actually write that line. We've treated them as statements, but realistically, those guys are expressions. Is that a true statement? Pun intended. They're expressions. Is that a true statement? So we would never, so a statement is like a standalone thing, right? We could say statements end in semicolons. That's going to change a little bit once we get into loops in our if statements, because if you think about like Java, those things typically do not end in semicolons. They actually have a block statement following them. Okay, but a semicolon is not illegal. You can put a semicolon there. It's not going to break anything. But in any case, when we think about resolve A, this guy is not actually a statement. He's an expression. Expressions are parts of statements. Make some sense? So if we back up here for a second. We're going to say statement versus expression. A statement is a top level directive in our language. Give a couple examples. We might say, remember a int a is equal to 5, something like that. I'm going to say which end in a semicolon. An expression is, and we can also say a statement is a collection of keywords and expressions, right? So like in any programming language, you can't name your variables with a known keyword. Like you can't name a variable named if, because if is a reserved word in the language, right? So when we think about statements, statements are going to be collections of keywords as well as expressions, where I'm throwing operators and all those things into the thing of keywords, reserved words, symbols. So here under keywords, we're going to say reserved symbols. If, for, plus sign, less than, ... Just to kind of give you an idea. Things that are built into our language that already have meaning. Okay, so, and expressions, where an expression is logic that needs to be evaluated, but does not stand on its own. And therefore does not end in a semicolon, but rather is a part of a larger statement. That makes sense? So we're creating this idea of having expressions and statements rather than everything being a statement. And we can see this in evidence in Java. So if I come into my, we'll just do it in driver here. if I say int a is equal to 5, that's a defined statement. That's a remember statement in our language. Perfectly allowed. But I can't just say a. I can even just say a semicolon. That's an expression, right? It's an expression that demands I resolve it. Make some sense? Okay, so that's the kind of animal we're dealing with here. So we want to go back through and we want to redefine this idea. Right now, our language actually has a single statement type. It has a remember statement, but then it actually has a single expression type, which is a resolved expression. Make sense? And we might say that even though right now we built our resolve statement, where's my syntax here? We built our resolve statements, well, we built our resolve expressions as if they were statements for testing. This is actually not legal code in our language, correct? Because we decided that looking up the value of a variable, resolving a variable is not actually a statement. It is a expression. For instance, we would be asked to resolve the value of a here. We would be asked to resolve the value of 7 here. And we saw that, oh, well, if I can parse it into an int, I'll just treat it as itself. Otherwise, if it's not, I'll go ahead and I'll look it up in my variable environment. That's fine, but notice we don't have the word resolve here. We could say, well, we're going to resolve a plus 7. Things start getting a little bit verbose there. We might prefer a syntax that looks like this, and that's okay, because we're handling it as part of a larger single statement. Make sense? So if I start breaking this down, we're going to say this guy is a statement because it has a semicolon. We're going to say that these guys are bad statements. We have semicolons just to make it work for the last homework assignment. Okay? So this guy is a statement. So we're going to process through this statement. What kind of statement is it? It's a remember statement. Fine. Pretty straightforward. We've already written remember statement, but the version of remember statement we've written so far handles only very simple versions of what's on the right-hand side of the equal sign, right? In fact, it just assumes it's a literal number, right? We can't even, as of right now, we can't say remember int c is equal to b, where we'd like to be able to do that, correct? Okay, so we're going to say I can't do this yet. Similarly, remember int c is equal to do some math or whatever, also becomes a problem, right? So we also can't do this yet. All right. So what we're going to do is we're going to make this guy work first. We're going to make a remember statement. This whole thing's a statement. We're going to make it understand the possibility of the right-hand side being a variable. Or, well, we're going to make it possibly a variable for right now, but for homework, we're going to add do math. It could possibly be a larger expression. And what I mean by expressions is we would also never write do math a plus 7, right? If I go into driver here and I say a plus 7, actually Java does treat that as a statement. It's funny. Okay, a plus 7 is technically a legal line of code. Oh, no, it was just because I had that in the previous line. Yep. So we wouldn't write this guy as a statement. It doesn't work standalone. We need to do something with that value, right? Because it's an impossibility for me to use that value as I have it written. I got to remember it. I got to directly use it as a print statement or an if statement, or I got to do something with it, right? Okay. So these things would be considered expressions, not statements. All right. So our remember statement we need to beef up a little bit. So under our parser, we currently have this idea of a remember statement. I'm going to add something called a resolve expression. All right, and resolve expressions are going to be kind of like statements. Okay, but it's going to be an expression type. So I'm going to steal most of this just to give myself a baseline for it. So I'm going to say new class. We're going to call this an expression. And we're going to say an expression has an expression type. Just like our statements had a type, we're going to have expressions might have like a resolve type, or it might have a math type, do math type. We're going to see how what we do with it. But for right now, we're using, this is like our abstract class. In fact, we could even make this an abstract class that we never intend to actually create instances of. So if you've worked in modern object-oriented languages before, when I put abstract in front of something, we're actually given the directive to the compiler that we are not allowed to create instances of expressions. Similarly, we are not allowed to create instances of statements. Instead, this guy exists as a building block for more complex statements or expressions. For instance, a remember statement or a resolved expression. So we can create instances of resolve expressions, or we can create instances of remember statements, but we can't create direct statements or expressions. So before we were choosing not to do that. Now we're going to be policed by Java because we've defined this as abstract. Java's going to say, if we ever try to create one of these directly, Java's going to say, you can't do that. You got to use one of the specialized forms of this. So we would call this better programming practice. All right, so I created this thing called an expression. And an expression is going to have an expression type. We'll see how that works here in a second. And we'll go ahead and we'll put in for our output our two-string thing. This is an expression, and we'll just put in the expression type. So really, this guy is a mimic of our statement for right now, right? It's the same thing, just we've called it an expression instead of a statement, so we can use this guy as our baseline for things that are expressions. Now I'm going to go ahead and we're going to use something built into Eclipse called refactoring. And for my resolve statement, I'm going to right click on this guy, and I assume this lets us do it. I'm about to change it to an expression. That's what I'm doing. I'm refactoring it to be an expression. Okay. Refactor. So here's refactor. I'm going to say rename. The hope is any place I use resolve statement, it will now get turned to resolve expression. Correct. They indirectly create it because he's asking the question. No, they're actually instances of remember statement, which is a statement, but the instance that was created was a remember statement instance. So here, let me show you an example. So here's an example of, I come out here to driver real quick. I cannot make a statement S is equal to a new statement. I'll just say blah for the name of the statement. Okay, I can't do that because it says that, oh, statement cannot be resolved to a type. Hold on. It's in parser, so I need to import parser here. Oh, I already have parser. Okay, now it knows about it. Okay. Notice over here, though, when I hover over it, it says statement cannot be resolved to a, I misspelled it. Get my right. Cannot instantiate the type statement. Okay, that's what abstract means. But now I can say, what is it? Remember statement. S2 is equal to a new remember statement. And remember statements take in a type, a name, and a value, all as strings. So I'll just int A5 like that. And then I need to give myself, here, I'm just going to do this. All right, so notice here, I'm allowed to create an instance of a remember statement. I am not allowed to just create a statement. Even though when I create an instance of a remember statements are built in terms of statements. So a statement is being created. His name is super, right? But I'm not allowed to directly create a statement because it's abstract.
So the extracted class is basically using the abstract class.
That's it. Yeah, in fact, we would say, and I'll put it in, we'll just put a little slide here. Abstract classes exist for the sole purpose of building other classes off of them through inheritance. We cannot directly create an instance of an abstract class. Instead, you must create an instance of a class that inherits from an abstract class to get the features of the abstract class. Make sense? All right, so let me get rid of these couple of things here. I'll just cheat like that. Just say give us everything from parser. All right, so now what I'm going to do for my resolve statement, we've decided these guys are not actually statements. These guys are actually expressions. So I'm going to rename him. So I'm going to go down here. I'm going to use refactor. Refactor is a software engineering term. So when I say rename it here, it should change it in all places that I'm currently using it. So it's kind of a convenient thing because I've used resolve statements in a couple of places in my program. This should change it to resolve expressions or whatever I rename it to. So I'm going to say rename this guy. I'm going to rename it to resolve expression. And then it lets me choose update references, update similarly named variables and methods. That might be playing with fire a little bit. It probably wouldn't make a difference for us right now. Actually, you know what? We do have a resolve statement. Let's see what that does. I'm interested in that. And then let's go ahead and hit finish. So now I have now it's called resolve expression. And I'm going to change this guy so that he extends expression instead of a statement, even though that's relatively meaningless right now. Go ahead. Well, both. I mean, we're changing for our convenience right now, but we're also, we've now added a new definition. We've said that statements are one thing and expressions are a different kind of thing. They're related to each other, right? Statements are collections of expressions and then some other stuff. So basically what we're saying is expressions, they don't exist on their own. They need a big brother to help them work. That makes sense? Where up to this point right now, we allowed this guy has just become an expression, no longer a statement. So this line of code would now be illegal. Well, should be illegal once we finish fixing it. Okay. So we've made, and I know it might seem like something small, but it actually is going to make our language a lot more powerful, because as we are processing statements, we are going to have to take into consideration that a statement is made up of keywords as well as other expressions. Make sense? And when we have an expression, we have to process that expression, deal with that expression. Okay? So let's go into our parser first. So we have parse resolve. Notice this guy returns a resolve expression. So we're building a resolve expression out of this guy and his name. We'll leave it like this for now. We saw that it updated these things in here. Remember statements, they're going to still work the way they worked before, but the value for this, so if we look at a remember statement looks like this. This will always say remember. This will always be a type. Right now, we only support a single type, int. This will always be a variable name, correct? So this guy is always going to be a string. It's this guy that could now be that is now an expression, right? He could be a literal expression where he's just like a 7. He could also be a variable expression where he's something we need to resolve. Make sense? Okay, so we've updated our language to now say this guy over here is anything that's an expression. And you see how now the expression is part of a statement. Okay, it's an abstraction. It doesn't get us that far right this very moment, but it really opens up our language to allow us to do some much more complex things now, if we write it. Okay, you with me? All right, so let's put it back to a 7 for right now. So let's get back into our parser. Because remember, the process here is we have syntax. Syntax gets parsed, then it gets interpreted. Okay, that's how our fight works. Right? We write spider syntax, it gets parsed into something else, which then gets interpreted. Okay. So when we call parse resolve, when we call parse remember, and we'll go ahead and we'll deal with this resolve expression here in a second. When we call parse remember, we're taking in a type, we're taking in a name, and this guy is a value. I'm going to call this guy a value expression, really to drive the point home that he's more than meets the eye. All right. He is a value expression. And what do we do with expressions? We have to parse them. Make sense? Right now, we have the idea of something called parse, and we are dealing with the idea of, we're calling parse statement because our syntax is a collection of statements, right? We have, our lines are separated by semicolons, so we have a statement followed by statement followed by statement. So we're always parsing our statements at the top level. But within that, we now have to have the ability to parse expressions. So this guy parses the top level statements within our language. We're also going to have a static void parse expression. And we'll go ahead and take an expression in as a parameter. well, he'll take in a string representation of an expression. I'm calling in an expression here to again remind us that this guy is more than meets the eye. He's not necessarily just an int. Okay, so we'll call parse expression on this. And right now, expressions in our current world are only resolve expressions, right? That's the only kind of expression that we're currently supporting. So we're kind of upgrading our previous assignment to now work for these things called expressions. So we're going to go ahead and we're going to determine which kind of expression this is and parse it. All right. And we'll go ahead and have this guy return an expression that we'll be able to use. Okay. So but we'll have it. You'll see how this works here in a second. Okay. So he's going to parse that expression and then ultimately return the expression he parsed. That's my idea for him right now. Okay. So we're going to go ahead and take our expression, and our expression might look like, well, let's say he looks like this, or looks like this. We need to determine what kind of expression he is. Okay. Some of our expressions are going to be, they'll start with a do math, something like that. So you may have it separated by white space, something like that. Or we treat it to ignore white space and separate on keywords. We'll evolve this as we go. We're not going to go make it too perfect because we're only going to have so much time for our language. But for right now, we can assume that we only have one kind of expression. Let's go back to my parser. Right now, we only have a single kind of expression. That is a resolve expression. So we're just going to assume that that's what we're looking at. Once we add math expressions, we'll have to ask, if it's a math expression, do this. Else, must be a resolve expression. Okay? So we'll go ahead and say that it's a resolve expression. Well, what's a resolve expression? A resolve expression has a name, that is the variable we want to resolve, okay, the value we want to resolve rather. All right, and then it goes ahead, and I'm going to just change this to say resolve expression for my type there. So what we'll go ahead and do in our parser is we're going to return a new resolve expression, passing it the expression. Keep in mind that when you go to do your homework, you're going to have to beef this function up a little bit. Right now, we only have the existence of a single expression, right? Resolve expressions. Later on, we're going to have more complex expressions, okay? So we're going to go ahead and create a new resolve expression, and we're going to return it. Now, it's going to come out of here as a generic expression. All right, now who uses parse expression? Parse statement does, right? So right now, if I'm looking at a remember, that means I'm going to remember something. And a remember, parse remember, takes in the type, the name, and then the value expression. It's this guy that I need to be more careful about, okay? So I'm going to say, remember expression, RE, is equal to parser dot parse expression. I'm going to pass this guy value expression. I wanted to parse that expression and ultimately give me the remember expression. Yeah, what about it? Oh, I'm sorry, resolve expression. So as my resolve expression, now coming out of here is going to be a generic expression. So I'm going to assume right now it's going to be a resolve. Actually, you know what? Just to well, no, I've shown you enough tools for this. So we're going to say this guy is a remember expression. That's what's actually, I'm sorry, still a resolve expression. So he's going to be, we know he's going to come out of here right now as a resolve expression, even though we're returning a generic expression, knowing that in the future, we're going to have other kinds of expressions other than just resolve expressions. All right, so he'll boil down to a resolve expression. We'll store it in a variable RE. And then when we build our remember statement, we're going to get the value associated with RE, which is our resolve expression. And when we say, well, we'll say get name for it, but it's at least built into something that is a bit more that we can work with. So a remember statement, when we build one of these guys, he's now going to take in a value that is a expression. And value here is an expression. For right now, we're going to return, I'm just going to keep it as return value for right now, which is an expression. As we go through, we'll adapt this when we get to the interpreter side of this. Okay, right now we're just parsing. We're turning it from our syntax into something else. And expressions need to be evaluated at runtime while the program's running. All right, so a remember statement is built with a type, with a name, and then the value of it, which is currently in the form of an expression. So we're going to take in and right now the only kind of expression we have is a resolve expression. So back in our parser, if we're dealing with a remember statement, I'll go ahead and build I'll parse the expression that we're dealing with. I'll parse the expression we're dealing with, and that is the value expression. We happen to know for the exact moment that that expression must be a resolve expression, right? All right, but we're going to go ahead and we'll parse that. It'll come out as a resolve expression because that's the only kind we have right now. We'll store it in this. And then when we build a remember statement, we'll build it with a type, a name, and then the expression. Okay, so now we have our remember statement, and that's for parse remember, which takes in a remember statement. And what are we doing with that parse remember? This is from our parse statement. Parse statement is going to say, if it's a remember statement, add to my list of statements the result of calling parse remember on the pieces of that, where the last part of it should be another expression. Make sense? Okay. Now, we don't have the idea of a resolve statement anymore. And since statements are the only thing that gets added to our list of statements, we no longer will be dealing with resolve statements. Resolve statements are now part of our remember expressions. Okay. So we call parse remember, Parse remember says we're going to go ahead and get our resolve expression, the third piece of that. So we're going to pass that into parse expression. Parse expression only has one kind of expression right now, so it's going to return a new resolve expression, passing it the expression that was given to this guy as a string. Parse resolve is what we're calling down here, right? Actually, you know what? We really should call return parse resolve of that expression. Because we want to go ahead and rely on our expression parser to do this, just keep it modular. So parse resolve will be the guy that will take this expression and ultimately give us an expression. So parse resolve will take in a name, it'll build that instance for us, return it. So it's doing the same thing we did before. We're just doing it inside of this method. So this guy boils down to, in this case, it should boil down to a resolve expression, which we are returning as a generic expression in preparation for us to have more expressions in our language. Okay, so again, we have this idea of a generic expression that is the base for all of our other expressions, but right now our language only has one kind of expression, a resolve expression. We will be adding a do math expression. All right, so we'll parse resolve, and remember the job of the parser is just to turn our syntax into objects that can then be interpreted. Okay, so now I have an idea of a remember statement. That's what's going to come out of this guy. So parse statement ultimately is going to add a remember statement. And a remember statement is going to be built in terms of a value expression. But that's going to get housed within the remember statement, that expression. Okay, because notice here, I build my resolve expression and I pass it as part of the constructor for my remember statement. And that's the guy that then gets added to my list of statements. So now my interpreter only is going to know how to deal with remember statements, but it's going to also know how to go and resolve expressions. So let's now go to the interpreter. When we call interpret, we already know we only have one kind of expression. That's a remember expression. So if it's an instance of remember expression, we're going to go ahead and call interpret remember expression, passing it our interpret remember statement, passing it our remember statement. Here's our interpret remember statement. Okay, so first of all, what are we doing? We're just directly adding a value. But this guy right here, he doesn't necessarily give us the value we need. We have to run that expression. All right, so a remember statement has a name, that part's correct, but we need to resolve the value of that remember statement. And the remember statement's value is an expression. We're actually just going to call this guy get value expression, like that, and he'll return the value. I don't think refactor will work on this guy. I think we've seen it before. So let's go back here to, I mean, you're right, it should work, but I think I've done it and it doesn't work, but we only have it in one place now. So we'll test it sometime where it really gives us value. So before we can do anything else, we're going to go ahead and we're going to get the expression E from rs.get value expression. We'll even call this the value expression. All right, so that's our expression. We need to resolve this expression before we can actually remember anything. So that means we're going to have a resolve expression function. I'll make it void just for a second, and then we'll change it to whatever makes sense soon. Actually, right now, I think they're all going to be ints. For now, it's going to be an int. So we'll call this guy resolve expression. He'll take an expression E as a parameter. Right now, we know we only have one kind of expression, although we'll go ahead and ask the question. If E is an instance of a resolve expression, okay, if that's the kind of animal he is, then we want to go ahead and we want to interpret our resolve, and change this to expression. And he's going to take in a resolve expression, and he's going to try to do something. All right, but this guy's no longer going to be void. He's now going to be an int. He's going to ultimately spit out an integer, right? He's either going to spit out the literal integer that exists, or he's going to spit out the result of looking something up in our variable environment. So if it is, and we're no longer putting this into our output because now it's part of our statements. Okay, so expressions don't get directly added to our output. Instead, they're part of, that's why we're returning a value now. Instead, they're part of other statements. So we will try to just take the name and turn it into an int. If that works, we're done. If that doesn't work, we'll try to, and actually I'll just go ahead and return. I'll return that value. If that works, great. If it doesn't work, then I'm going to go ahead and I'm going to return the result of looking it up in my environment. Otherwise, I'll get that error message saying that I couldn't find it in my environment. So same logic as we had before. And then this guy is going to be a rather than doing system.err, let's do this. We're going to say row runtime exception and that should make it work. So this is like our, hey, nothing went right. I couldn't find this variable. We'll throw it as an exception, which will also exit the program. All right, so if we call interpret resolve expression, passing it a resolve expression, we'll go ahead and try to get the integer out of it, assuming it's, so this guy tries to treat it as a int literal. So that will either work, or we will return the value of getting it from our environment. So we'll say, if not a literal, look it up in our environment. Otherwise, all is lost, runtime error, interpreter crashes, blah, blah, blah. All right, so this is what interpret resolve expression does. So now down here for resolve expression, we're going to go ahead and we're going to return spider interpreter dot interpret resolved expression, and I'll pass it E. Now he's expecting it as a resolved expression. So I'll pass him E, which we've determined is a resolved expression because of this question right here. Some of our newer languages, like Swift, and Java actually has some facilities for it, but it has something called unwrapping a variable, where we would do a test like this, and then we wouldn't actually have to cast it. It would unwrap it to the value we tested it for. Not the end of the world, but you wouldn't have to do the type casting right here to specify that it's a resolve expression, because you know it's a resolve expression because you just tested for it. Oh, I see. What's called is get expression value. Like that. Take an expression and it'll return the integer value of it. And then if we're still alive here, we'll go ahead and say throw new runtime exception, not a known expression type. Get I'll go ahead and give myself a getter and setter, a getter for this. So that inside here, I'll be able to say e dot get expression type. So it'll give me an error message saying not a known expression type, but then whatever expression type it is. And that would then remind me that I probably need to write another else if in here, because right now we only have a resolve expression, but pretty soon we're going to have a math expression or a do math expression or whatever you want to call it. Okay, so get expression value is going to ask if it's an instance of one of these guys, return the integer value of that. So interpret remember statement is first going to get the value of that expression. And get value expression is going to be for my remember statements. That's the expression. We're going to go ahead and get the value of that expression. So we have a get expression value. So we'll say int answer is going to be equal to get expression value of value expression. Okay, and that guy should give us our integer version of it. before here. Then we'll be able to go into our spider interpreter and add our value, and the value is going to be called answer. That's what we resolved up here when we got the value of our expression. And we're already handling that logic of try to deal with it as a literal. If it's not one of those, look it up in the variable environment. That's what we did right up here. Resolve expression. We'll try to pretend it's just a number. If that works, great. Otherwise, let's look it up, look up the expression in our variable environment to get you the integer that's associated with that variable name. All right, so that's what all this does. We'll grab the expression associated with the value expression for this remember statement. We will ask our spider interpreter to get the value of that expression. It's going to give us that as an integer answer, because right now we only support integers, right? Later on, we'll have to make this a little beefier as we add more features to our language. But for right now, we only support ints. So the type of expression that we're going to have on the right-hand side of that in our remember statements is either going to be just a number or a variable that we need to look up that's going to boil down to a number. One of those two. Okay, so one way or another, we're going to get our answer by calling get expression value on our value expression, which is going to call interpret resolve expression, which is this guy, which is either going to give us the integer version of it, or it's going to resolve it from our environment. And then we'll go ahead and add that variable with the answer we've resolved to our variable environment. Tell them that we got that answer and that was added to the variable environment. So same output as we had before, but now we're able to deal with it at a more complex level. So right now I should be able to do those things. I should be able to, these are all remember statements. This is a resolve expression. This is a resolve expression. This is a resolve expression. This resolve expression boils down to a 5 because it just parses 5 out of the string 5. A 7, it parses a 7 out of the string 7. This one will try to parse the integer out of the string B. It'll fail, which will then have it go and look up B in our variable environment, giving us our remember B, which should be a 7. So C is equal to 7 then. So current variable environment, we have A equals 5, B equals 7, C equals with the old value of B, which was 7. So there's our values there. Why are we getting a file not found? Where was that from? It's from the parser. Yeah, I know. Let's do this. Oh, I must have in my I had an extra space there, so it had one final split. There we go. We can fix that in the future. We'll just trim that line to make sure there aren't extra spaces before and after it. So now I should be able to put extra spaces in here if I want. And it should still work. Okay, so now our the right-hand side of a remember statement now expects us to give it a expression. Okay, where an expression right now can either be a literal expression or it can be a variable expression. Okay, so if we were gonna, I'm gonna go ahead and add a is this in our default package? I'm gonna add a new file. And we're gonna call this guy syntax readme dot txt. So inside here, we'll go ahead and we'll say we have statements and we have expressions. We'll just keep it with our interpreter. So right now, the only statement we know how to do is a remember statement. So remember type var name equals expression, where our expressions are resolve expressions. Int literal or var environment lookup. And then I'll say types right now is only int. So our expression here must be one of these expressions, which right now we only have a resolve expression, which boils down to either a int literal or a var env lookup. We'll say int there because that's what it always returns for right now. All right, and then the only types we support right now are int. All right, makes sense so far? All right, so we currently support this. Now, what we want to be able to do is we want to be able to do something like a remember int d is equal to do math of a plus b. Or remember int d is equal to do math c plus 4. Something like that. So we want to add a do math to our syntax. And do math is an expression followed by a math operator followed by an expression. Our math operators are going to be plus, minus, times, divide, and modulus. This is modulo int division remainder. In fact, I'll put that on its own line. All right, that makes sense. So add for homework. This is homework 5. For homework 5. Let me go ahead and push this. Starter code for homework 5. I'm going to steal I'll just give it here. Add to our language the ability to have expressions of type do math, where do math expressions take in two expressions and a math operator, and ultimately return and ultimately boil down to the result of doing the correct math. Boil down to an int that is the result of doing the correct math. For example, you should support syntax like this. That make sense? So you're adding the ability to be able to remember. We still only have one kind of statement, remember statements. But now instead of having either a variable on the right-hand side or a literal, we now can also have do math expressions, where do math expressions take in an expression, followed by an op, followed by an expression. And we've defined that in, here I'll say C, what did I call it? Syntax README. Interpreter for more details. Something like that. Submit your GitHub link as well as the self-assessment. Now this should not be too bad now that we've given a model for how to handle expressions, right? So what we've done today is I've converted our interpreter over to something to handle statements of expressions. So now we're just adding a new type of expression, math expression, which actually we'll call do math, right? Which should do something very similar to what a resolve expression currently does, except instead of having to resolve only one expression, it has to now resolve two expressions, right? And then you're going to need a function that will do the correct math. Resolve the first expression, resolve the second expression, then if it was a plus sign, add them together. It was a minus sign, subtract them. It was the multiplication sign, multiply them, so far and so on and so forth, right? All right, so this should not be too bad, but you'll want to go through the current code and make sure you understand it. Let me add this to our assignments, and all this stuff should be graded now after my long nap yesterday. Actually, my voice is okay today, isn't it? Like it's off, but it doesn't hurt. It's held up okay, I think. Maybe because today's finally completely cold. I hate this type of time of year. Okay. That's due on Monday. Oh, it's the same link, but I can add it again. Yeah, I'm just updating the original link, but for convenience. There. Okay, so questions about any of the stuff we did today or what I'm asking you to do. You're definitely gonna, if you didn't follow along pretty well with what we did today, definitely go back through the video and kind of make sure to bring your code up to date with mine and make sure you're understanding what we're doing. But effectively what we did today is we added a new type of component to our language. That is, statements are made up of keywords and expressions. So we still have a resolve thing like we did before. We've just turned that into an expression type, which is now going to open our language up to be more powerful. So what questions do we have regarding this stuff? Yeah, so he's asking, how do you figure out which operator is what? So, you know, if you have something like this in your do math, this expression, so, you know, you'll split this, right, on spaces, on white space. So we already know how to do that. So the first part will look like this. You'll say if it's a do math, do this, else must be a resolve, right? We only have two expression types, right? We'll have a do math and we'll have a resolve. So the resolves are catch-all. If it's none of the other ones, it must be a resolve. So you'll say if it's a do math, we need to do math. Part at bucket 1 will be our first expression. Part of bucket 2 will be the operator. Part of bucket 3 will be the next expression. And then the operator is just going to be if statement. If it's equal to the plus sign, do addition. If it's equal to the minus sign, do subtraction. Make sense? Yeah, no, you were probably overthinking it. It's just a question. You'll ask something like this. So let's assume this is parts at, let's say 0, 1, 2. If parts at bucket 2 is equal to the plus sign, then, you know, do addition. Make sense? Because this is going to just be, actually, it's going to be a, it's going to come out as a string. So if I'm going to write this correctly then for you, dot equals the string plus, like that. Then do addition.
I was thinking the same thing, that are we going to use the ALU functionality, or do we have to write the code for understanding on language about what's the addition sign?
Oh, you can use the built-in add. Yeah. So what they're asking for those of you online is, do you have to do any sort of weird magic to like reinvent what addition is? No, you can use Java's addition. So if this was the case, then you would you know, boil down to resolve expression of parts at bucket 1 plus resolve expression parts at bucket 3. And actually, we call this get expression value. I think Blade told us to update that. So if we're doing addition, get the value of part 1, get the value of part 3, and add them together using Java's add. All right. Other questions?
So in the two expressions, we can take the different math operator or the same.
Well, there's only going to be one math operator.
Okay.
Yes, because so like our expression is going to look like this. A do math expression looks like this. So you'll have, this will boil down to an int, this will boil down to an int. So we're either going to resolve this, or like in this case, it is just already a literal. And we already managed that. If I give my interpreter this, it'll give me the value of A from the environment. If I give it this, it'll give me a 4. If I give it this, it'll give me a 7. So then the only thing you're doing is you're taking advantage of something we already know how to do. And then you're saying, I'm going to do that twice. I want to get the int value of this guy, the int value of this guy, and then I want to perform this math operation on them.
Okay.
So there's only going to be one math operation. And I guess for this assignment, just so you don't confuse yourself, you don't have to support something like, you know, A plus B plus do math of B plus 4 or something like that. It actually wouldn't be a big deal to do that, but for your assignment, let's just go one level. All right, other questions? And the reason why it wouldn't be a big deal is because what are we doing here? We're calling get expression value on this guy. We're calling get expression value on this guy. Well, if this guy looked like this guy, get expression value already knows how to deal with do math. So what I'm saying is you might accidentally make it work for a whole bunch of these guys nested together. It's not like extra hard to do it that way. I'm just, for your own thought process, don't worry about that. But if you're going to write everything as get expression value, when you get the expression value of this, it's going to give you a number. When you get the expression value of this, it's also going to get you a number. Make sense? So this is an expression and an expression. What do we do with expressions? We call get expression value on them. That's what we do to them.
So I think based on this pattern is actually get the value by, but get the variable value by the value, right? It's not by passing the reference. So once say for supposedly you are saying C equals to A B plus B, and if you change the B later, and then now you're trying to resolve C, actually it is not reflected by the later.
Correct, but that's how languages work anyways. Yeah, so Blade was saying that when we set C equal to B plus 4, let's say, or B plus A, C's value will be equal to the current value of B plus the current value of A. You know, it won't have some sort of reference to the variable B, so that if later on we change B, the value of C then changes as well. No, and just like in Java, just like normal programming languages, if I say C equals A plus B, C is a value that's equal to the current value of A and plus the current value of B. If A and B change after that, it doesn't modify C.
So then, so when you have this like if we initiate a variable or something, so does it do any reference related to other parts of variable or no? If you are just comparing those two variables.
Not right now, but once we get to the when we say like remember C is equal to like an array type, then we're going to store a memory address, and then it's a reference. But our language doesn't know about those yet. But yeah, that's the future thinking, right? So once we know about reference types, then when we store stuff, we'll either store a memory address which points to a value that needs to be resolved, or we'll store the literal value. Right now, we only know how to store literal values. There's no memory addresses or anything that we're implementing. Sound good? All right, questions, comments, concerns, bribes? All right, I will see everybody on Monday. And Monday we should be online because we don't like using that other classroom, but we should have class Monday. I think it's supposed to stay cold, so I shouldn't have allergy issues.